Okay, so on this one, we are going to find the slope of the tangent line to this graph, which is a circle, x squared plus y squared equals 2. And we're going to find the slope of the line tangent to the graph at the point 1, 1. All right, so this is just finding the derivative. The slope of the line tangent to the graph is the derivative. So that's what we're going to do. We're going to find the derivative. And since y is not isolated in that problem and you can't really isolate it, that's when you have to use this implicit differentiation. All right, so the slope of the tangent line is dy dx. So that's what we're trying to find. So we've got x squared plus y squared equals 2. So the first thing we do is we find the differential of each term. So the first term is x squared, the differential of that. Remember, d dx of x squared, that's the derivative of x squared, is 2x. So the differential of x squared, you multiply both sides by dx, and you'll get 2x dx. So the differential of x squared is 2x dx. I'm just going to erase that so I'll have room. Oops. Back to my pen. Okay, so 2x dx plus 2y dy, that's the differential of y squared, equals the differential of 2 is just 0. All right, so we found the differential of every term. Now we need to divide everything by dx, since we're looking for dy dx. So in terms of dx, we're going to divide everything by dx. The dx cancels here. So we have 2x plus 2y dy dx equals 0. Now we solve for dy dx. So we subtract 2x on both sides. And now we divide both sides by 2y. So dy dx is equal to negative 2x over 2y, which is just negative x over y. All right, so that's the derivative of this function. Now we're supposed to find the slope of the tangent line at the point 1, 1. So that's what we're going to put in for x and y here, and that's going to be just negative 1. So that would be the slope of the tangent line to that graph. All right, so that's example 34.4. And if you look on page 184, you'll see a picture that shows you what that looks like with this circle and its tangent line. Okay, so this next example says find the points on the graph of x squared plus y squared equals 2 where A, the tangent line, is horizontal. Oops. So remember, a horizontal line has a slope of 0. So we're looking for where this circle has a tangent line whose slope is 0. That's what horizontal is. All right, so we already found the slope of this the tangent line to this graph, and that is negative x over y. We found that already. So dy dx, we found in the last problem, was negative x over y. And we want that to equal 0. All right, so that's going to equal 0 whenever x is 0. Okay, so when x is 0 on this graph right here, so again, the only way that tangent line could ever have a slope of 0, the only way it could ever be horizontal, would be when x is 0. All right, so if x is 0, if we put 0 in for x on this in this equation right here, we're going to get 0 plus y squared equals 2. So we know that y has to be plus or minus the square root of 2. So the 2 points where the tangent line is horizontal would be 0 square root of 2 and 0 negative square root of 2. All right, so if you look at page 185, they show you a picture of those two tangent lines to the circle. All right, and then for part B, again, remember, we already know that the derivative of this function, the slope of the tangent, any tangent line to this function is negative x over y. And now they are saying the tangent line is vertical. All right, the tangent line is vertical when you have no slope. All right, so that's going to happen whenever y is 0, because that would make this undefined. All right, so when y is 0, if we plug in y equals 0 into the equation, we get x squared plus 0 equals 2. So that means x squared is 2, which means that x must be plus or minus the square root of 2. And so that means that the 2 points where the tangent lines to this circle are vertical are going to be the points square root of 2, 0, and negative square root of 2, 0. All right, so that was example 34.5. Okay, so this is the last example, and this one's a little different. It's hard to understand the graph of it, but we'll just do it algebraically and just follow the process. All right, so given that x and y are both functions of time, and x squared plus y squared equals 2, find dx dt. All right, so now we're going to use implicit differentiation, and this time we'll divide everything by dt. All right, that's all that means. We're finding the derivative of this function with respect to t time. All right, so we do it exactly the same way. We find the differential of each thing in the equation, this equation, and then we'll divide everything by dt instead of dx or dy. So 2x dx plus 2y dy equals 0. And then we divide everything by dt. And so we have 2x dx dt plus 2y dy dt equals 0. And now we're going to solve for dx dt. So we will subtract, so we'll have 2x dx dt equals negative 2y dy dt. And then we'll divide both sides by 2x. So dx dt equals negative 2y over 2x dy dt. And so the so dx dt equals this, and of course we can cancel those 2's. All right, and so then in part B they're asking us to find dx dt, so this thing we just found, at the point 1, 1 when dy dt equals 7. So all we have to do is plug in the point 1, 1 for x and y, and then plug in 7 for dy dt. So dx dt is going to equal negative 1 times 7, which is negative 7. All right, so that may not make a lot of sense as far as application goes, but that's going to come later. This is just a process you have to learn to do, and that's all you got to do right now.